Hi friends, in this video we will be going over medication calculations using dimensional analysis, the types of problems we will be solving for. It'll be asking for how many mLs, drops per minute, and time. Before we get into the practice problems, let's go over a few rules and some tips that will help us out. So do not use a trailing zero and always put a zero in front of the decimal place. So this would be correct. This would be a med error. This would be a med error, and this is correct. For example, if you get an answer that is 0.76 mLs, this could be mistaken for just 76 mLs, which is very different than 0.76 mLs, so you'll want to put the leading zero in front of it. Similarly, if you get 7 mils for an answer, you don't want to put 7.0 mLs because that could be mistaken for 70. So these ones are the correct ones. These ones are not. Something that helps me a lot is if I start with what I'm solving for and then work backwards, which you'll see in the following problems we're about to do. You can also not have half a drop. So if you're solving for drops per minute, you can't have half of a drop. So if you're solving and you get 1.2 drops for the answer, you're going to want to round it. So this 2 is below 5, so it's just going to be 1 drop per minute. When you're solving for time, make sure to calculate it out into hours and minutes. You're not going to go tell the doctor that the patient will be ready for their procedure in 1.5 hours. You need to say 1 hour and 30 minutes. Also, memorizing your conversions is very important. On tests and things, they're not going to have a table up there for you to go reference. So 1 kilogram is 2.2 pounds, 1 gram is 1,000 milligrams, 1 milligram is 1,000 micrograms, and 1 liter is 1,000 milliliters. Most all the conversions that we'll be memorizing is this 1 to 1,000 ratio. Other things that would be helpful to memorize is like there's 60 seconds in a minute, there's 60 minutes in an hour, which we all know since childhood. Something else to remember that so you don't get confused is that drop factor is always going to be drops per mil. Drops per milliliter. And that can also be abbreviated as DF for drop factor. So if drop factor equals 20, that'll be 20 drops per ml. Okay, so let's get into our practice problems. Morphine 12 milligrams is ordered. The syringes are marked 10 milligrams per ml. How many ml will the nurse administer? So I start by putting this O here for what is ordered, the H for what we have, and the X for what we're solving for. So we are solving for ml. So I'm going to go ahead and put ml there. What we have is the 10 milligrams per ml. And what is ordered is that 12 milligrams of morphine. So 12 milligrams there, 10 mg per ml there, and then the ml is here. So I start with what we're solving for. So we're solving for ml, so ml equals, and then look where you find ml in our information. It's here. So we're going to put that up here first. ml over 10 mg times, well, we need to get rid of this mg, so where do we find mg? We have it here, so times 12 mg, and then if there's nothing under the 12 mg, we just put 1 for our placeholder. So now we can see if our things cancel out. So mg cancels mg, and we're left with mLs. That's what we want. Now we multiply across. So that's just 1 times 12, which of course equals 12. And then 10 times 1, of course, equals 10. And then you divide that, and you get 1.2 ml. That's your answer. On to the next problem. So the order is for naloxone, hydrochloride, which is our Narcan, 1.2 mg IV. The ampule is labeled 0.4 mg ml. How many ml will you administer? So what we want to solve for is mLs here, so I'll put ml here. The doctor ordered 1.2 mg, find that right there, and the ampule, so what we have is labeled 0.4 mg ml. So again, we'll start off with what we're solving for. We want ml, so ml equals, let's find that ml here, so ml up top first, and then 0.4 mg. Okay, we're going to want to get rid of that mg, so we're going to times it by mg up there, so 12 mg. Have our placeholder here. And now we can cross those out, and we're left with mils. So multiply across the top, that's going to be 12 over multiply across the bottom, 0.4. which equals 30 mLs. So we will be giving 30 mLs. Next problem, administer 300 ml in 6 hours. The drop factor equals 15. What is the drip rate in drops per minute? So now we're going to be solving for drops per minute. So drops per minute. What we have ordered is 300 ml in 6 hours. And then what we have is the drop rate. So 15 drops per ml. So what I like to do, the easy conversions, I like to get them out of the way, especially if they're with time. We know that we want our answers in minutes here, but we have hours here. Since we know that there's 60 minutes in an hour, we're going to times 60 by the 6 hours, which equals 360 minutes. So this number here is going to replace the 6 hours here. Now let's solve the problem. So we'll start here, drops per minute, because that's what we want, equals, we're going to find something that has drops in it, found it there, so up here first we have drops per ml equals, so we need to get rid of that ml, so we have the 300 ml here, oh here, that's supposed to be times, so 300 ml over the 360 minutes. Okay, so now we can cancel things out. So ml cancels out ml. Now we have drops per minute like we want. So we are going to multiply across. 15 times 300 equals 4,500. and then 1 times 360 is 360. You divide these two, and you get 12.5. But remember, you can't have half of a drop, so we're going to round that. So 5 and above, give it a shove. We're going to round it up to 13 drops per minute. Next problem, infuse 150 ml of an antibiotic at 33 drops per minute. Drop factor is 10. What is the infusion time? So what we're solving for is going to be time, and how we know what units the time will be in is the only other measurement of time in here is minutes, so it'll be in minutes. So we're looking for minutes. The order is 150 ml, and then part of that order is this 33 drops per minute, so I put it on the same line as this. That's a comma, 33 drops per minute. And then what we have is always the drop factor, if there's a drop factor. So that's going to be 10 drops per ml. Now let's solve for our minutes. So minutes equals, let's find our minutes, and that's right here. So we're going to put it up top and first. So 1 minute over 33 drops. Okay, now we need to get rid of our drops, and we have drops here. So 10 drops per ml. Okay, now we need to get rid of that ml, so that's where we're going to use this 150 ml. So 150 ml over our placeholder. Now we're going to multiply across. So 10 times 150 equals 1500 over 33 times 1 will still be 33. So we divide that out and we get 45.4545, repeating. So we're going to go ahead and round this 4 down because it's below 5, and we will get 45 minutes. That's how long it will take for that 150 ml at a drop rate of 33 drops per minute to infuse. Next problem, 2 units of blood are ordered. Each unit has 450 ml. Both units are to be completed in 6 hours. The drop factor is 10. What is the flow rate drops per minute? So we want our drops per minute. And then what we have ordered is 2 units of the 450 ml. So we're going to do 2 times 450. That equals 900 ml. And we want that in the 6 hours. So over 6 hours. Then what we have, of course, is that drop factor of 10, so 10 drops per ml. So we'll start off with what we want. So we want the drops per minute. Let's find something that can cancel. Let's start with the drops and put it up top. So up top and first, we have it here, 10 drops per ml. Okay, we need to cancel out that ml, so we have the 900 ml there, so 900 ml over the 6 hours. Okay, so we don't want hours, we want minutes. So this is where our conversions come in. This is how you can incorporate that kind of conversion into the problem itself instead of just doing it individually up here. Both ways work just fine. So now we're going to times this, so we know in 1 hour there's 60 minutes. So now let's cancel out, so ml, ml, hours, hours, and we're left with drops per minute. So now we'll multiply across. So when you multiply it across, 10 times 900 equals 9,000. Multiply this across, 6 times 60 is 360. And then when you divide that out, you get 25, so 25 drops per minute. Next problem, which is also our last problem for this video. If you want to know heparin calculations, that will be the next video. So the physician has ordered gentamycin, which is an antibiotic, 80 milligrams IVPB every 8 hours. The medication is dissolved in 150 ml of normal saline using 20 drops per ml. Find the rate in drops per minute needed to give the medication in 45 minutes. So what we're solving for is this drops per minute. So drops per minute. And then what we have is that 20 drops per ml, so 20 drops per ml. Okay, so this is what can trip people up a little bit here, is the ordered part. So when you see he orders the 80 milligrams of this antibiotic, but it's dissolved in 150 ml. This up here is in this, so we can disregard this 80 milligrams here. We just need this 150 ml because that 80 milligrams is in that 150 ml. And we want that 150 ml infused in 45 minutes. So how this is going to look is the 150 ml here over 45 minutes. And the every 8 hours doesn't really matter because we're just figuring it out for this one time being given, not the whole day. So let's start with what we want, the drops per minute. So equals, we want to find the drops. Here's the drops, 20 drops per ml. We want to cancel out the ml, so we have the 150 there. 150 ml over 45 minutes. Now we can cancel things out, so ml, we're left with drops per minute. Now we multiply across, 20 times 150 equals 3,000, and then 1 times 45 is 45. You divide that out, and we're going to get 6.66666, and then there's a 7 over there. So we're going to round. We're going to go to the next decimal place over. We're going to round up because it's above 5. So we're going to round, this is 66.66667. So we're going to round up to 67 drops per minute. That is it for this video. If you are wondering on how to do the heparin med calcs, I'll be doing that video next. Please comment any questions you have below and I'll try to get back to you. Like and subscribe, that really helps me out. Thank you for watching and I'll see you next time.